Science is different from mathematics in that it's based on observation. Math is about relating things, whether those things are real or not. So math and science are complementary tools for understanding how the natural world works. Now, an observation I say here is a directly perceived, verifiable fact. By direct perception, I mean directly via human senses. You see or hear or taste it, or directly via scientific instruments. For example, if I say a snowflake is melting at a temperature of 0 degrees Celsius by looking at a thermometer, that's an observation. Now when I say verifiable, I mean that observers that are under the same conditions will make essentially the same observation. So anyone can see that what you're saying is true, given the same conditions. It's important to carefully control and specify the conditions that you've made an observation under. If a procedure for making those controlled observations, for collecting them, is called an experiment. And sometimes observations that are collected experimentally are called empirical observations. There's two types of observation. Some are qualitative or non-numerical. For example, I can say a clear sky is usually blue. And that can lead me to a question: why is the sky blue? A quantitative observation includes a number. Sometimes it's called a measurement, or it's called data when there's more than one. And they're preferred for detailed study and confirmation of things. For example, if you point a spectroscope at the sky, it'll give you a graph like this that shows the different wavelengths of light that you're seeing versus how intense it is. Now, if you look at this peak here, it stretches across maybe 450 nanometers up to 485 nanometers or so, the very peak of it. And that's usually what we perceive as blue. We call that kind of light blue light. Now we have some more specific information that might point us more clearly towards an answer to the question, why is the sky blue?